Hi everyone, this is Adam Mazouz, and in today's session, I'm going to be talking about building a cloud strategy with Pure Storage Cloud Block Store. I work in Pure Storage as a cloud solution engineer. I'm focusing on cloud and virtualization, and I'm responsible for testing, documenting, and visualizing the why and how Pure Cloud Block Store in the cloud. I've been in the IT industry for over a decade now, and recently I've been recognized as a VMware expert and also part of the AWS community builder for storage category. In this session, I will try to cover a couple of pieces. First, I will go into the why we've done Cloud Block Store, so a bit of a public cloud overview, and then go into the different details around how the cloud efficiency works, how resiliency works, how you can deploy and manage storage in the cloud from different options and also from Cloud Block Store. And last thing is how we can build DR and high availability architectures or strategies in the cloud using Cloud Block Store. And I can promise you there's going to be a lot of technical demos, so stay with me. Usually when I started building in the cloud for a couple of years ago, I had the hype or the promise of what the public cloud started with their businesses. They want to make things easier, more cost efficient, and better protected and available. And then there's a couple of pillars here what they really promised us. They promised us for cost flexibility. You can shift away from building data centers and procuring IT infrastructure to pay-as-you-go model or as a service model where you can pay on demand. The other thing is how elasticity is being a part of all the cloud services. You can scale up, you can scale down based on your demand or the needs of your workloads. Availability is actually being provided from different data centers across the globe with the cloud introducing a new terminology called availability zones in each one of these regions of the global to ensure the uptime and operational of your business. Security is actually something is being handled by in-house monitoring and measurements from the cloud hyperscalers themselves. However, with all of the cloud has to offer over the years, we have seen some common pitfalls that organizations have come across or struggle with. The first one here is, as I already mentioned before, it's easy for you to start consuming services as on demand or pay as you go. But with that ease of cloud services procurement, then there's going to be the effect of building silos resources and projects that may not have the oversight in your IT organization, which will lead into something called shadow IT. The second pillar here is data mobility and egress charges, bridging the gap between an on-premises or a private cloud to the public cloud. This is all going to bring additional layers of complexity into your network infrastructure and also the other resources and concepts for you to learn. And above that, the cloud, when you want to get your data from the cloud is going to charge you for the egress charges. Third is when you're protecting against data corruption or ransomware or invalid patch update that put your whole system into panic mode, the cloud is not actually immune for that. I know that we suffer that on the premises, but when you go to the cloud, you still have all that problem. But to solve these problems, what really matters for your business impact and reputation is how fast I can restore my data from snapshots. The fourth thing here is resiliency. And resiliency can mean a lot of things. Ability to keep data online, business continuity, and actually high availability is treated with usually doubling or tripling your cloud infrastructure between availability zones among the cloud, the cloud global regions in order to replicate your data and protect you. But that data is going to be non-transparent for you as a user. So with all of that in mind, how can Pure Storage can really help mitigate some of these factors And before I really jump into what we really offer, I just want to have kind of a slide where I'm going to go and summarize what we've said already. We said that on-premises and the cloud are really different from the terminology and the fundamentals here. Resiliency means difference, what the resiliency means in the cloud. Efficiency is on premises or private cloud is usually built on thin provisioning, data reduction, deduplication, compression. Efficiencies in the cloud means totally different things. And usually all that thin provision stuff is our thicker provision in the cloud. So as you can see, the right data strategy is a key for your unifying your cloud and your on-premises data centers in order to bring the best for your business and run your workloads anywhere. Enter Pure Storage Cloud Block Store. In short, we call it CBS, and it delivers enterprise-grade storage functionalities in the public cloud. What we've done with Pure Cloud Block Store is we looked at how FlashArray is built, or what is really sourcing the powerful FlashArray from the Purity software that runs in the operating environment on the controllers of that FlashArray, and we took that and we software define it and build it in the cloud using native services. The first thing to realize is that it's the same software, and it's built and designed for running tier 1 applications in the cloud. No compromises on reliability or performance. And today is actually available on AWS and also Azure. And it could deliver to you high availability, efficiencies, etc. But if you were just going to have a step back and look at why a public cloud why we don't just use a native block services. As a matter of fact, the way we built Cloud Block Store is we built it on top of those cloud block services, but we built it to bring the best out of those, to make those native block services better. The public cloud has an ever-increasing number of storage options. If you're really an Azure user, you might be aware of the Ultra SSDs, the Premium, the Standard. Each tier of the storages can be difficult to understand, or sometimes they're easy to use, but there is also lack of enterprise-grade features from data mobility, snapshotting, or the fact that, which is a common concept in the cloud, is that you have to thicker provision your capacity and performance, or usually they are linearly attacked. So if you want more capacity, you have to increase your performance, and vice versa. So what we've done here is we enhance the public cloud storage infrastructure by offering on top of that cloud native services a wrapper or a layer of our software. Purity software runs on top of Cloud Block Store, and it takes and optimizes the storage that you already have running on AWS and Azure. Usually my colleague referring to it like the frosting on your cake. It's just going to make it more delicious. Common use cases here before we start jumping into how we can deploy it, how we can use it, and how we really can build workloads and strategies on top of Cloud Block Store, is that Cloud Block Store is mainly or what we commonly see from our customers are using it for cost-efficient block storage. The way that how we can offer thin provision volumes that they can be deduped and compressed. So rather than just going siloed resource storages, you just need to aggregate all your data behind one appliance or one offer that's going to offer you cost efficiencies. Disaster recovery is another major use case here, from all the native replication that we offer on the Purity platforms between FlashArrays or between Cloud Block Stores or among all of those. And the third thing is how you can test and dev your workload environment in the cloud. And also based on as I told you from disaster recovery, all those replication tools and services can be used for cross-cloud data migrations. So you can unlock your on-premises to the cloud, or between two clouds, or between public and private, or the cloud that you built. So let's dive into how you can deploy a Cloud Block Store. So as I already mentioned, it's now publicly available on both marketplaces in Azure and AWS. You can deploy it when you go to the marketplace. What you need to do is you actually just need to go to find the offer, and that offer, when you just fill all the requirements, what I'm going to show you in the next few minutes, then there's going to be a full template that's going to be triggered from that marketplace, and then all that infrastructure, the underlying infrastructure that Cloud Block Store is powered on, is going to be located on your within your subscription, within your account. There's two different approaches for how you can deploy Cloud Block Store. The first one, through the Azure portal, I am going to call it manual because I'm going to show you some automation around it, is you need first to build and prepare a couple of prerequisites from virtual networking, from IAM roles, or user identities. And then once you have those in your subscription or in your account, as you can see here, the example I'm showing you is the Azure example. Once you have those requirements, you go to the marketplace offer, enter those fields, requirements, and that is going to deploy you all that services you can see under one managed application, from 2 controllers to all the managed disks that we provision to bring you a Cloud Block Store storage-defined, software-defined storage in your subscription. So let's go and see how we can achieve that manually. Let me unshare my screen.
Znasz szkolenia SysOps DevOps Polska? Przeszkoliliśmy już setki osób. Dołącz do grona absolwentów naszych kursów.
So I will navigate to an opened tab here. I have my Microsoft Azure. I already logged in, so I need just to navigate to the marketplace. If I search pure storage, I think I have a typo. I will have multiple offers. I will go to the product deployment. This is where you can bring your own license. I'm going to show you how you can deploy a free license, or what we call it, the evaluation mode license. So once you choose the version you want to deploy, you just need to select the resource group you want. I can just go, maybe I have one that I already deployed before this presentation. I can select the region where I want this to be located. Keep in mind that Cloud Block Store is a zonal resource, means that it has to deploy in one zone. And then I can choose a model. I give it a name, your domain name, where it's going to be assigned to your array name, so you can form the full qualified domain name. The license key. This is usually when I want to test something. I just need to go CBS trial license. This, if you use this, it's just going to give you 45 days of a trial for the product. You just need to go to, as I told you, there's a managed identity. You have to create it beforehand. The networking, select a subnet, a virtual network or a VNet, and a subnet for each interface of type of the Cloud Block Store. There is 4: system management, iSCSI, replication, etc. You can tag them so you can easily categorize them for your billing or for other policies. The JIT, or the just-in-time access. This is for to give the support access. And you just need to create it. I haven't finished all the requirements here, but once you do this, it's just going to take 15 minutes to deploy. But for now, let's try to do that on a different ways. So if I go back to my slides, I just need to show you the next one is to automate deployment with with our Terraform provider. So we built a Terraform provider. If you're already aware of how Terraform works, it is going to be a very handy demo for you. So we have a one provider for CBS. You can check the documentations. I've already built what we call the quick start module, where we have, let me go to my GitHub here, where you can actually just select an example. In that example will be connected to multiple modules. So this is not just going to deploy you a Club Lock Store on your Azure subscription, or it will also create all the prerequisites that I've mentioned before, from the virtual networking, NAT gateway for the outbound access. It can create you the jump host, the key vault, and then it can create you the array. So I've already put this in practice, as you can, let me show you here. It took me 15 minutes to deploy everything from one single apply. I just need to do Terraform. Let me just move this a bit. So this just show me the output, but if I want to really use it, I just need to do Terraform plan. And that's going to plan what's going to be really configured. Once I finish with this, I just need to do Terraform apply, and all my prerequisites and the Club Lock Store will be installed and deployed in a specific zone and region of my choice. Okay. Okay, let's go back to the slides. Just to summarize what I have done here, if you want to do the same thing, if you want to deploy CPS using Terraform, you can just go and clone that GitHub. I'm going to show it in the files within this presentation as well. And then you just need to modify your Terraform TFVARs. I didn't mention this earlier, but I'm going to show you later on. The second thing is you just need to initialize the Terraform plan and apply. And that's how you can deploy a Club Lock Store within 15 minutes in your Azure subscription. Moving forward into another use case here. So we tackled first how we can deploy Club Lock Store, how we can find in the marketplace, or how to automate it using Terraform. Next is to understand the value behind Club Lock Store. And one of those values actually is how you can make the cloud more efficient. As you can see here, there is most likely 4 things that we have to mention. The first one is thin provisioning and data reduction. If you want to deploy or to provision a storage or an Azure managed disk, the native block services in Azure, you need to first to thick provision your capacity. Then you have to specify a provision capacity, a provision IOPS, and bandwidth for your disk. This will end up with over-provisioning or under-provisioning. So you might end up with insufficient storage during your peak times, will going to impact your workloads. So if you think about it, this is how Club Lock Store is going to bring some cloud efficiencies. All the storage that we provision are thin provision that can be easily extend or shrink down. And the data, once it's done, is stored on the backend of Club Lock Store or CBS. It will then deduplicate it and compress it and store it efficiently. From a storage performance as well, is that what we offer from a CBS perspective is the full performance for any size of your volumes. If you have 1 gigabyte or if you have 1 terabyte, you will end up with the same performance. So there is no tied down or a linear relationship between how much capacity I want for my storage. So I can get the similar amount of that in performance. The third thing is the compute. Usually, most of the managed disks will require you some vCPU reservation or specific backends IOPS that will tie down into a specific instant type, and that's actually going to be, you have to charge on those as well. The fourth thing I have to mention here is the networking. So we can reduce the ingress and egress data, because what we've done with storing an efficient duplicated copies of the data. So when we're going to be sending data back and forth between two cloud block stores in two regions, or between cloud block store and a flash array, we will make sure that we're going to lower the bandwidth requirements, and you will pay less for the egress charges as well. So let's go and have us just look at a demo of how cloud block store console or the management look like. So just use the management IP address that from my output here. Let me show you again. Terraform output. This is the one I redeployed. I have a management endpoint. I just copy pasted it, and I just need to log in using the default username and password. And this is how Cloud Block Store looks like. If you're already familiar with Flash Array, it's exactly the same console. And if you already have built any scripting or CLI commands, it's going to be the same thing as well. So creating a volume is just a matter of going to the volume and clicking on the plus sign, give it a name, this volume. I need then provision it how much I can. I can go from 1 gigabyte into 1 petabyte of data, because now it's all thin provision, so I can create how much I want. I think I have an error in my test volume. There is no spaces, and create. So now I have 1 petabyte of throughput, even though of capacity, even though like I don't have that in the backend storage, but this is only thin provision. I can also just click on any volume I have, and I can start protecting it. Protecting a volume, or there should usually go into an auto protection group, or I can specify a protection group where I can go and create frequently snapshotting, or I can select a target for my to replicate those snapshots. So as you can see here, this protection group has all the 4 volumes that create on that array, and I can select a target. I don't have a target currently now. The target can be another Cloud Block Store, a flash array, or even an object storage in the cloud, either that AWS S3s or an Azure cloud. Let's go back to our slides, where we're going to go into the second use case here, which is dev testing or hybrid analytics. The reason why we're always talking about dev testing in Pure Storage is based on how we're storing data. A flash array volume is a 100% metadata. We don't really allocate storage, we don't reserve it, we don't plan what we require. And so making snapshots from that metadata is just going to be a part of pointing to what has been changed. So what you're going to end up with, 0 performance overhead if you want to create a snapshot of 1 gigabyte or 1 terabyte is going to be the same. It's going to be instantaneous. And snapshots are not incremental. That means that when you create a snapshot and then you create another snapshot, if you want to clone that snapshot to a volume, you're going to have a full capabilities of what the data resides in it. There is no dependencies on previous data allocated from the original copy. And you end up with a full performance. And as well, if you want to recover anything to anywhere, that means that that snapshot can be replicated, as I told you, to another flash array on the premises or another Cloud Block Store that runs on a different region. So how we can put this into real use case? Think about if you have a database, or you're running your SAP HANA or any workloads that require snapshotting and cloning to different dev test environments, or different testing or batching over the night or over the weekend. You can just do that using the snapshots cloning, which is non-existent in Azure today, especially for the high tier performance. So you can create thousands of those snapshots, and clone them are almost 0 cost. Only the data changes are unique, and this is what we're going to be storing on the backend. Let's do another demo, and let's show how, since I mentioned databases, let's show how we can automate the process of deploying a SQL or an Azure SQL database and mount CBS volumes to that database. I will automate the whole process. I'm going to be using Azure Bicep. If you're not aware of it, Azure Bicep is the native infrastructure as code that service that can be used on Azure resources, and it can automate your deployment. And then I'm going to be using Pure Storage PowerShell SDKs to authenticate to my existing Cloud Block Store and configure volumes. The last thing is I just need to use custom data or the script during initialization to mount those volumes into my Azure SQL VM for data volume, log volume, and TIM volume. First, let me go and show you how I put together the Bicep. This is how the Bicep is constructed. I already have here the configurations, the PowerShell SDK configurations, and also also the operating system configurations for configuring iSCSI and initializing and formatting the disk so it can be presented to the SQL database. Worth mentioning here, let's try to change this. Maybe I'm just going to try to put it into 500 gig since everything is going to be efficient and thin provisioned, so no problem with adding storage here. And then last thing, I just need to copy this command, and I need to use Azure login, but I already logged into my Azure here. I just need to run this. This will take around, I think I have one problem here. Let me just fix it. We need to cut this part. Let's say from when to where. So the last thing is we need to copy this command, and I just need first to open my directory here where I have everything put together, and this command will take from 5 to 10 minutes for deploying the virtual machine, a SQL database, and then mount the volumes from Cloud Block. So let's get into this a bit later. Moving forward, while my database is still being created, let's go and uncover the last use case I'm going to mention here is the disaster recovery in the cloud. Pure storage style is to have data anywhere, and it can be mobilized anywhere that your workload is actually running, from a sync replication between two flash arrays, between even different tiers, from an X tier to a C tier, to getting those copies and snapshots to the cloud. And this is not only certainly part of the asynchronous replication, but it can also be continuous replication using ActiveDR, or synchronous replication using Active Cluster between two Cloud Block stores, where you can stretch your volumes and achieve a 0 RPO and RTO. Let's dive into each business use case and explain how we can use a native replication from Pure Storage to achieve that. If we're talking about business continuity, where you need almost a 0 RPO or a recovery point of objective to a 0 RTO, which is the recovery time objectives, Active Cluster can achieve that using a stretched storage cluster fundamentals, where you can your database or your VMware cluster can stretch between those two sites. The second thing here is if you have more relaxed RPO and RTO, you can use some other business resiliency technologies like ActiveDR, where we continuously replicate as low as 1 second lag behind from source to destination. The third thing here is using async replication to send snapshot-based replication with as low as 5 minutes between each snapshots. For long-term archives, you can store those snapshots or offload them to an object storage into an AWS S3 or an Azure blob, so you can keep them on a low-cost tier. And when you need that snapshots, you can rehydrate them, or you can retrieve them to the source array, to the same cloud block store where you send them, or to another region. Let me show you 2 examples or use cases here. The first one is the SQL Service Business Resiliency for hybrid cloud deployment, where you have your workload actually running on a failover cluster on premises, and then you start using active cluster and then sending one snapshots or async snapshots to the cloud. With this, you can achieve mission critical databases or business continuity between those data centers, and also bring the benefit of the on-demand, creating the cloud services as needed. The second use case here is we can use CloudSnap or the long-term replication tier to send data or offload them to a bucket, and then that bucket can be replicated natively on using some S3 inter-region replication to another region. And then if you need or you have an outage on one region or one array, you can just bring that data to a newly deployed cloud block store, rehydrate that, and create new VMs and attach them. This is what we call a cloud DR use case, but it can be proven really good for low cost or more relaxed service level agreement where the RBO is above 1 day. Before we jump into this this lab, let's go and revisit my Azure SQL databases I've been deploying. It's still been running, but we can just go to my Microsoft Azure here. Let me navigate to my resource group. I can see that I have a VM. I called it SQL test VM earlier. Connect to it. And then I will try to get the public IP. I have already added here a fake username, my username, and a fake password. And this is what I'm going to be using. It's still being provisioned, but let's try to see if my storage is already being presented here. So if I go to disk management, I can see that my VMs, because I did not save that file. I have them on the previous storages, which is 50 and 20 and 10. I didn't apply that file to this script. My apologize. All right, so let's go back to the last demo of the day, where I will show you how you can replicate a SQL database to Azure with having in mind that this database can go back. So the terminology we're going to be using here is fail over a database or fail it back from between on premises to the cloud and attach it to a new Azure native SQL VM. The first thing here is that my on-premises or the source database is actually a virtual machine that runs on VMware, and it's utilizing a vVol-based storage, or the externalized storage policy management from VMware on a flash array. The reason why we're using that is because vVol will keep the same file system as the operating system or the ingest VM. I have my database on this drive, so I need first to keep it a read-only, and then I create a backup from it. As you can see here, I'm creating a backup for my database, both log and data files, and I'm gonna assign them or copy them to my volume that I will replicate to the cloud and then restore that backup. Going forward to the flash array, I can see that I have one tab for flash array and one tab for my Cloud Block Store. In order to create a target or for your protection group, you need to first create the array connection. In order to create the array connection, it has to be initialized between both arrays. And once you do that, you can see it here as my demo CBS SQL. This is the array. Then I have to move to the protection group. I have to create one if I don't have one existing, and then add my volume as a member of that volume group, which is already here. I need to add it to my new protection group. I don't need, within a protection group, there's two requirements here. The first one, you either have to use a local or a remote. So now I'm enabling remote and disabling local snapshots, and already added the target for my CBS. A few seconds after that, I can see my my snapshots got replicated, and now once I have them on the CBS on the cloud side, I can just clone my volumes. Once I clone them, as you can see here, I have to navigate to my the volume itself, create a name, and then volume snapshots. Once this is done, I can see that this is my volume. And the last thing I need to do here is, and actually there's two things you can do once you clone a snapshot, is copy that volume snapshot. You can see it on the volume tab, and then connect it to the host. The host is actually already being configured. I can see that here. Once I connected it, I can see that all my drives came up. And if I scroll down, I can see that I have my SQL migrate with my backup. I just need to restore it. So I opening my SQL Studio, where I just need to find the backup, find the drive letter, the backup, and then restore my database, and then my database is back up and running. This is one way of doing database replication. The other way is you can use not a sync replication, as we can see here from creating a snapshot, but what you can use is using ActiveDR continuous replication, where you can you have a read replica on the cloud while continuously replicating all the data changes from the source. With that, there is no need. You just need to keep your database offline or in the read-only mode on the cloud side. And once you need to have the need for that, you just need to promote that volume, and then you can return from move from read replica to read write or a full mode database. This was my, I think you have to cut this as well. This was my presentation. Let me stop sharing. It's taking too much. This was my presentation about Cloud Blockstore and how it can deliver you cloud efficiencies, storage efficiencies, data reduction, and also transparent data replication between regions or between your on-premise or the cloud. Thank you for watching.